The engine that we made was the world's first, right? It was a single piece 3D printed rocket engine. The entirety of the rocket engine is printed in a single shot. The launch pad we flew from was a private launch pad which was allocated to us within the premises of Sriharikota by the government itself. India is good for manufacturing at scale, but original innovation, I think we are still yet to make that mark or have that brand globally. And that, I think, the onus is on the current sort of deep tech startups to go there and say, hey, we are doing something original from India.
Thank you for joining Once Changing the World, India's first future tech meets sustainability podcast. And today, I'm delighted and honored to have with me Mr. Srinath Ravichandran, co-founder and CEO of Agnikul Cosmos, one of India's most exciting space tech startups. Agnikul Cosmos is revolutionizing access to space with its pioneering work on small satellite launches. The company's flagship product, Agniban, is a highly customizable 3D printed semi cryogenic rocket designed to carry payloads of up to 300 kgs to low Earth orbit. Agnikul made history when they successfully test fired Agnilet, the world's first single piece 3D printed rocket engine, and has also established India's first private launch pad and mission control center at Sriharikota. So, Srinath, really appreciate you taking time and being part of the podcast. I mean, before we get into the questions, just wanted to start with getting your thoughts about the moon landing, because, there are a lot of skeptics who say that the moon landing never happened, and the skeptics have some sort of points out there, like the flag, which appears to wave despite the absence of atmosphere on the moon. The lunar photographs, it shows no stars in the background, and then some photos appears to have these rock with these letters C inscribed on it, and then the hazards of the Van Allen radiation belts, and the other point is, this was in 1960s, and it's 2025, and we still really not managed to send people back to the moon, though there's NASA's Artemis program, which is planning to return humans to the lunar surface in 2026, and then China plans to do like a moon landing in 2030. So just wanted to get your thoughts on the moon landing. What do you think? I mean, was it fake? Was it real? Will be great if you could start with that.
Oh, it's absolutely real. I don't even have a bit of a doubt on that. I think a lot of people have come up with various, theories and hypotheses on why it could be fake. I mean, it's a bit like the flat Earth theory, right? And there's still a group of people who believe Earth is not exactly a sphere or oblate, so spheroid, but instead it's a flat plate. So I think these hypotheses and these conspiracies would continue to exist. But I think there are multiple other, proofs that humans were on the surface of the moon. So there's no doubt about that, and we continue to see proof of that as we make more and more missions happen. Their moon has been also imaged in excruciating detail now. Right, there's very high resolution imagery available, and we can see now track of that as well. So, yeah, I don't even think there's a bit of a doubt in my mind about whether we actually landed on.
Perfect. So I always wanted to clarify with someone who's in the space tech. Wanted to get your thoughts on UFOs and unidentified aerial phenomena. Because I mean, just recently, I think there's an Indian person called Nikhu Madhusada. He's an astronomer who has detected what they call the most promising sign of to date of a possible biosignature coming from this exoplanet, which is some 124 light years away. They're calling it the K2-18b planet. So what are your thoughts on UFOs? Because this is something which has been there are, I mean, again, skeptics, pointing towards evidence, but somebody who's in the space tech, what are your thoughts on UFOs?
I think life should be out there in some form. I don't know if it is in a form that we recognize. I don't know if it's hydrocarbon based. I don't know if it is going to be, appearing or like what do you call it? Like I don't think it need not be anthropomorphic, right? Because we are used to life in a particular way. We always think life forms will be in that way. but it may not be that way. But it's just like, there are so many stars, and each of them have so many planets, and these findings that are happening either through James Webb or through Hubble, the number of possible planets, exoplanets, where we're talking about planets that are orbiting stars other than the ones that we usually think about. This is way too many, and there will be some finite probability to say that all of this life evolution happened. So I think that's actually quite possible.
You're from IIT Madras. I had interviewed Professor Satyanarayan Chakravarti, who's your advisor. Somehow IIT Madras seems to be doing all the right thing, from the top inventions to the creative minds that spawned, with XR, with Professor Manivanan, then with AI, with Professor Balaram Ravindran, to space tech and Hyperloop and eVTOL with Professor Satyanarayan Chakravarti. What is it that IIT Madras is getting right that the other institutes are maybe failing?
Oh, I think IIT Madras has a framework, right, in terms of how you could bring an idea into a commercial setting and actually create a startup out of it. Across all the IITs that I have seen, and across other incubation centers and all that also, I feel the best thing that IIT Madras did was to make this framework super clear, right? So you don't need to think about what it means to translate an idea into a startup. And because that is there, and then they, of course, they leverage that with the network from the alumni side, with building their own ecosystems around helping with the paperwork and so on. It's a lot of community support as well. So my understanding is many more IITs may have the skill, talent, and the right kind of ideas, but the platform to make that go to the next level is only available here. At least it's by far the best out there. That's all I would say.
Right. So, Srinath, would you be able to kind of elaborate on this? When you're talking about this, IIT Madras is the university out there here in India, which offers the framework, the idea to start up. I mean, you mean the entire ecosystem? Will be great if you can elaborate on that.
So, say for example, right, at IIT Madras, we have this context of a incubation cell, right? And this incubation cell has been specifically created, keeping in mind that when a startup comes out of IIT Madras, how the university or the IIT Madras incubation cell itself would get compensated, how the professors would get compensated, also what kind of early support is required in terms of setting up the entity, doing the initial company secretaryship, coaching people to talk to investors, finding mentors, tapping into the extremely powerful IIT Madras alumni network. All of these things are being figured out at that level. So it has become like, I know there is a platform. If I have an idea and I know what to do roughly with it, I can get started in a startup setting. That usually is not something so clearly spelled out in other places.
Right, and what I'm seeing is, compared to the other IIT institutes here in India, I think it's IIT Madras which is kind of doing the right thing when it comes to the deep tech spectrum, the entire deep tech spectrum. Because I remember I had a conversation with Professor Chakravarti almost like 4 years back, and that point of time he was talking about eVTOLs, and there was nobody else. I mean, eVTOLs and hyperloops and AI and things like that. I'm not saying that the other guys were not really talking about it, because I remember 5 years back, and I speak to people about AGI, and there was nobody in India would even talk about it, or was had like a clue about what AGI is. Because I think the normal approach here in Indian startups is like, let's go where the money is, and nobody kind of wants to touch the deep tech space. And that stands true even for the investor or the government, because I think 5 years back, right now I think it's all hip and it's all cool, after Sam Altman came here in India and gave that talk, and suddenly everybody kind of woke up and said, oh wow, we should do these cool things, we should do these futuristic thing, and we should really support or research a community and think about the future. Because I think even recently, the Ministry of the Commerce, Piyush Goyal made a statement that the Indian startups are kind of building all these e-com startups, ice cream startups, and things like that. But nobody is really looking into deep tech space. Somebody who's been invested in the deep tech space, and I personally have been invested in deep space since quite some time. We were amongst the first startup here who kind of build in hardware, AR VR camera, 16 camera rig, and nobody was kind of thinking about it. But when it's about Agnikul, obviously you guys are going like really really bold out there, building like a rocket. How difficult has the journey been, for a deep tech startup? It will be great if you could talk about that.
Yeah, so I think the country as a whole is still warming up to deep tech. It's still much better than how it was when we started in 2017. When Agnikul started, it was still almost a wacky idea, right? Was almost considered closer to crazy than to strong innovation, based startup. But that has changed. So today, I think we are at a place where, as a country, getting the first few million to do deep tech is okay. It's not impossible. But beyond that, I think it's going to be really hard. Beyond that, I think people are going to still look for the typical growth side metrics. And that appetite has also not come. We have not seen too many successes also there and so on. Right. So in that context, things are going to be a little slow only in terms of deep tech startups. I think three, four things in terms of deep tech, particularly original design from India. One is about getting the right kind of people. I'm still seeing the best of the best of the best design engineers and stuff. They still want to go outside the country and study or settle there. Right? That pull is still there. I mean, it has changed. The good part is you also see some reversal of the brain drain. People are coming back also. But still, it's like if you're a really good engineer, you go out, study, and then maybe you can come back is the mode. So that makes it a little harder to find the right kind of talent, right? But I mean, there are a lot of people, so you can still offset it. But I'm just saying that is one thing. Second one, I think, is in terms of money availability. Third one is in terms of generally convincing people across the world that original new design can come from India. For some reason, there is a lot of notion out there that India is good for services, India is good for manufacturing at scale, but original innovation, I think we are still yet to make that mark or have that brand globally. And that I think the onus is on the current sort of deep tech startups to go there and say, hey, we are doing something original from India. So, but that those are the 2-3 blocks that you'll have to overcome, right? But in space tech itself, actually, the good part is even though it's deep tech and all, the world has accepted that India as a country, at least at a space agency level, can do a lot of good things. ISRO is known for what it is doing really well. So there you get a bit of a breather, I would say, in terms of people accepting that India can do something in space. But it's worse in other areas actually.
I completely double when you say that India lacks that people or the innovation support system, and just I mean, OpenAI and DeepMind, they started somewhere around early 2000. Nobody believed in them. Nobody wanted to even touch them, because they started with that big vision of, okay, let's build AGI. And look at them, like from there to here, now they are the most expensive company. I think we need to create that nurturing environment towards deep tech startups who have a vision, because when you have like those really bold vision, that's when, and not just that bold vision, a startup or individual having that vision, we need the entire community to come together, and support, like the investors, who don't shy away from investing in startups with longer horizon, the government coming and supporting and saying, the industry coming and supporting, and I think that's when you will truly start seeing original companies coming out of India. It's not that the talent is lacking. What I see from my side is that maybe the ecosystem has still not come together. You being a deep tech startup, especially in the space tech area, how did you manage to convince investors to back a capital intensive and high risk venture like yours? And will be great if you could also explain what Agnikul Cosmos is and what you guys do.
Yeah. So about your first question about the ecosystem itself and support for renovation. So if I were the investor hat, right, and even though I've heard a lot of people in the early years saying no to us and all that, in some level, at some level, I have empathy. because there are two things that I have in front of me, right? One is I can go put out a check in a SaaS company or in a consumer company, right? And everything is probably in the short term game where you're supposed to make money for a group of people who gave you money, and that's how you created your fund. I think it makes a lot of sense to take a bet in those sectors compared to deep tech. And why are they incentivized, right? If I'm a rational investor, to some level I would actually say go with these industries, right? Because I don't think the investment game is about, at least from a pure fund management standpoint, is about backing original ideas, and those are all like, okay, those are good philosophies to have if you're able to return, right? Otherwise, what's the point? So I think in that sense I understand if instead of a consumer company and Agnikul, if both of them are being shown to a investor, the investor picks the consumer company. I actually understand, because that is how the investor has been, that is his performance measurement objective. That's how he is measured in terms of what he or she does, right? So yeah, that's how it is. It's just that maybe when you see bigger family offices, or when you see funds which are evergreen where they don't have to return within a short period of time, when you have all of these things come in, at that point in time actually you're able to do a lot more betting. Today that's not how it is, right? Very few evergreen funds, very few funds where directly the, like, it's a rich family or something that has made money doing innovation coming in and betting. So I think those kind of things will have to fall in place before you start seeing more bigger bets and original bets happening at a country level here. So that's my view on the ecosystem. Otherwise, there is support. There is support from academia. There is support from vendors and so on. So that is the first part. That's how I would look at it. So I think the second part about Agnikul itself, right? Yes. So in the beginning years for us, it was about educating the community. Business model can be built out of building a space product, right? And that was hard. And again, here investors and even vendors and customers, they are all very used to ISRO doing this, and so it was very much seen as a government project, not a private commercial project where you can make money or make profits out of it. So there was a lot of that, like the number of iterations of meetings it took to get a investor to be convinced was more, right? Because you're educating them about space tech, then you're educating them about rockets, then you're educating them about Agnikul, and then you're building conviction that your product works. So there is a multi-step process. What usually takes 2 calls will take 6 calls. And then people come and visit, and they see hardware, they see the engine, they see the computers, they see the software, and then the conviction builds, right? So I think that was the struggle in the early years. And of course, at that point when we started 2017, policy was not very clear, right? So people were also worried about things like, will India allow this, will someone say no to it, and so on. But today at least InSpace is there, and InSpace is very clear about allowing and promoting these kind of activities and so on. So the paperwork part of the problem is now sorted. Fundraising and educating investors, I mean, they are not in this sector, right? And of course, at least in space, again, SpaceX seems to be dictating a lot of things, and a lot of people just accept the fact that if SpaceX does something, it's probably the only way to do it. So fighting those biases and explaining that to people, those things take time. That is the struggle that we usually go through.
Completely. And thanks to first movers such as yourself, you've paved the way for those next few bunch of entrepreneurs who are going to come in the space tech, and they're going to have it much more easier because of the hard work that you guys have put in. So Agnikul, will be great if you could walk us through maybe the biggest challenges of building Agnikul, and the Agniban sorted, which is the world's first 3D printed rocket engine launcher. It would be great if you could talk about that.
Sure. So just to get the business case for Agnikul out there very clearly, right? We start with the customer, right? The customer is, for us, anyone who wants to launch a satellite, right? And satellites have completely changed in the last 20 years, right? They used to be far away, they have come near. They used to be few in number, but now they're a lot more in number. They used to be heavy, now they're light, right? So operating distance, size, quantity, everything has changed. But if you look at the vehicles that take these guys, the rockets that take these guys to orbit, that still sort of seems to be stuck in the past, right? So that is the gap in the market, right? Rockets are big and satellites are small. So the only way to fly a viable mission is by actually putting a bunch of these small satellites into one mission, one launch, and flying. But that comes with a lot of problems, right? Because you're solving for a transportation problem, and you're saying the only way to go from any point to any point is through rideshare. Just think of ground transportation, for example, and we say there is no such thing as dedicated rides. The only set of rides available are buses or trains. That's how the space market looks today, right? So it's very obvious that you should build smaller systems, smaller rockets to take smaller satellites to orbit. But then that's where the economies of scale, actually when you kick in, right? Like when you want to build a big system, obviously the unit economics are better, obviously the efficiency is better, the wastage is lesser, and so on. So when you want to conceive a small rocket, and numbers on the paper, everything looks great. In fact, even the physics would work. What won't work is economics. So when we started, it was very clear small rockets are needed. It was also very clear if you use existing technology to build small rockets, it will blow up on our face. There is no way we are going to be economically viable. So our job was to come up with a list of technologies that actually can be affordable even at smaller scale. So that is where the 3D printing comes in, right? And 3D printing is one example. We have a lot more things, but the idea has always been to say, can I come up with manufacturing systems or design or whatever else, the way in which we put our software together in a way where even at a small scale, it starts to be affordable. And then you're actually head on in terms of pricing, or probably even better than SpaceX in pricing. But at the same time, you're able to offer more than what SpaceX offers. So that has been the goal. So we identified technologies like 3D printing, particularly 3D printing of rocket engine, where the entirety of the rocket engine can be made in a very small amount of time and can be rapidly, executed. The idea of a mobile launch pad where you can go to the right location as far as the geography is concerned. Every mission seems to have one sweet spot on the planet from where it will be the best to launch. So you can think of those things also and put it into a launch, because today none of those things happen as far as the bigger rocket launchers are concerned. So all these technologies, you put it together. The engine that we made was the world's first, right? It was a single piece 3D printed rocket engine. The entirety of the rocket engine is printed in a single shot. The launch pad we flew from was a private launch pad which was allocated to us within the premises of Sriharikota by the government itself. So all of these things came together, and we successfully flew a rocket, a controlled rocket, not just a sounding rocket. It's a controlled rocket where you're actually tracking a trajectory just like you would do in a commercial mission. And we did that successfully on May 30th of last year. So that has been Agnikul's story, and now with all the tech validated, we are full on into the commercialization phase.
Right, right. How cool is that, Srinath? So, Srinath, when you're talking about 3D printing, where did the idea come from? Because, these rockets are obviously not small, these are large. I mean, even the small rockets are large. Like, I mean, to 3D print out like a large rocket, one piece, obviously, I mean, where did that idea come from? And how do you see the role of 3D printing evolving in the future of rocket manufacturing, both at Agnikul and in the global space industry?
Yeah, so 3D printing as a technology was, savior in a way, because it allowed us initially to iterate quickly, right? That's how we initially thought about it. Because 3D printing allows you to create hardware in much more complex ways, at a much more faster pace. You don't need to create a mold, you don't need to create a cast. You're not going through the typical metal manufacturing processes. And also, a lot of the work is done by the machine itself, right? So this is where the initial advantages were. What we, what pushed us towards us, or what we really try to innovate there, is to say how much can you take away from the human element and put it all in terms of repeatable processes with the machine. Because if you look at rocket failures or rocket problems, generally it's always an issue of quality. Very, very rarely there is a design issue, because usually design issues are figured out on the ground itself, right? So the only surprise element is someone didn't tighten a nut properly, someone didn't put the right nut, someone didn't qualify the material properly. So general rule of thumb is if you can automate, automate, right? And 3D printing just is so beautifully set for automation because it does a lot of things by itself. So we had to come up with designs where the entire rocket engine is 3D printed. The existing size of machines was a constraint, so we solved around that. We decided that we are not going to interfere in making of a rocket engine. The printer would do it. So that set some bounds on what kind of engines are possible, what kind of geometries are possible. It also gave us a ton of flexibility in fine tuning and making the system more efficient, right? We were able to squeeze out a lot more, efficiency in terms of fuel usage, in terms of cooling, and so on. And with all that, we came up with this, engine design where entirety of the rocket engine is printed in a single shot. So that's how the 3D printing part came together.
How safe is this compared to your traditional, designing and building out a rocket compared to like a 3D printing approach?
It's the same level of reliability. So when you're talking about safe, if you're talking about failures and so on, anyway, the engine goes through the exact same qualification process that it would go through, irrespective of the manufacturing, right? So whether you 3D print it or whether you take it conventionally, the testing program that will allow for the engine to fly is the same. And that particularly for liquid propellants, you can literally test the same engine on the ground a few times before flying it and so on. So this gives us a lot more, confidence in the mission. On the other side, even if you do conventional, but if you're doing it with a lot of humans involved, or you're doing, say, solid propellant based rockets, there is an inherent risk you're taking in terms of repeatability. I think we have taken that out of the picture as well with 3D printing and the regular qualification of IIT Madras.
Right. How cool is that? Because I think, in the future is going to become more and more autonomous. There's going to be more and more of these 3D printed rockets and things like that. Because I think in 3D printing, there's a 3D printing organs, there's 3D printing buildings, and now 3D printing rockets. I think the room is just, it's just going to evolve. Srinath, it'll be great if you could explain to us how big the space satellite industry is, what's the demand like, and maybe if you could walk us through the process, right from building to the launch to the deployment of these satellites.
Yeah, so I think the sector itself, the launch services market is about $10 billion or so just for the small satellites. If you include all launches, you'd cross probably 20-25 billion. But just in the small satellite market, we have about $10 billion of revenue to be made every year globally. And this is already excluding guys like, Starlink who have their own rockets, right? People who don't have rockets itself is amounting to this kind of a launch revenue over a period of time. Now, the way the process works is it's like you're booking a ride on a vehicle, right? So, just like in any transportation system, only three parameters apply. One, you need to know when you'll get your ride. Two, you need to know how much you'll pay for the ride and whether there is a minimum and how quickly the clock ticks after that. And third, it's about pick up and drop off, right? Geography. Like, will you be able to go from the right launch pad? And will you be able to will you be left at the right destination, or is there a last mile connectivity issue? Now, with a company like SpaceX, all these issues are problems, right? There is a minimum order quantity, so pricing could be, challenging. Waiting times are literally outrageously bad, right? 2 years. And they launch from fixed launch locations and they will fly a standard mission. If it works for you, great. If not, sorry, right? So that's the sort of the world we are in. So for us, the launch process for a customer engagement is we ask the customer for the mass of the satellite, we ask them which orbit they want to go to, and we'll ask them for a preferred location. And based on this, a rocket itself will be conceived for them, just for them. Dedicated launches are also possible, right? And we'll say, okay, given that we made it just for you, the price doesn't mean the pricing is crazy. It's still going to be in the framework of what they would have otherwise paid SpaceX and so on. So I think in that context is how we size our vehicle. And with that point, we're able to actually go and say, okay, now you come and integrate your satellite with my rocket. Then I launch the rocket and then I release my satellite once I get to, orbit. And with that, the journey is over.
Srinath, will you be able to kind of, give the applications of these satellites? Because I believe, satellites are used for communications, Earth observation, navigation, scientific research, as well as military application. It will be great if you could talk about the application. Is there like a specific area or a vertical that Agnikul is targeting to, looking to target?
So, see, the major reason why small satellites go to space today is for communication or for imaging, right? Those are the two things. You either go up and take photos, or you go up and you help with signal connections across different points. That said, there is a lot more, a nuanced set of applications coming up. People who are trying to use space as a platform, right? It's almost like saying, hey, I'll go to space because space offers me vacuum. I'll go to space because if I'm in low earth orbit, I'm in microgravity. I'll go to space because if I'm away from the sun, I can, be at a lower temperature. So these are applications where vacuum or low temperature or microgravity are required for prolonged periods of time. So, what used to be a destination focused approach, right? Before it was like, I'll go to space because I want to take a photo or for communication. Today, it's like, I'll go to space because it offers me something that is extremely hard to replicate on the surface of the planet, right? So that approach has started. So there's a lot more people. It almost feels like the app market, phone app market of 2008, 2009, right, where we didn't even know what is possible. We were all given a platform and it was affordable and many people started buying it, and then there was an entire set of use cases that no one thought was even possible, but people started coming up with it. We are there. Satellites are getting into the point of, hey, space just became accessible, now what? Every industry that I know of is now thinking of space not as a separate sector but as a tool, right? Can I solve my usual problems using space, as opposed to saying going to space is its own world? No, space is more of a tool, right? And I think that has started now, and yeah, and it's very global also in the way the market is. Right, there are people from all over the world wanting to launch from all over the world to get to orbit. So in that sense, it's actually a very united ecosystem overall, and that's how we try to position ourselves in the market as well. We want to be the single best small launch vehicle provider in the world with full focus on customer flexibility.
You mentioned about building your space launcher, 3D printing it completely, and obviously it's got like a bunch of other tech stack, maybe algorithms, and because it's an automated vehicle. Would you be able to kind of simplify it for the audience, as in what are those, like maybe those key components of making sure of building the rocket, making it go up to space, deploying the satellite, and having it come back? I mean, it will be great if you could talk about that.
Yeah, so the rocket is simply a transportation machine, right? So we can compare it with, say, a cab, for example, right? Just like a car, it has a fuel tank, an oxidizer tank, because you're in space, you need to carry oxygen also. Then an engine or a set of engines. And then you have that repeated in multiple places because you don't carry everything along with you. At a certain point, it's dead mass once your tanks are empty, and so you drop them off. Like, this is basically the context, right? Now, in the framework of this, what does a customer want, right? So this is how you offer a ride. But a customer wants to be dropped off in a particular orbit. They want to do the cheapest possible ride to get there, and you can make a ride really cheap by starting off at the right place, right? So the way we think about our rocket is, I'll go to the customer and literally ask for, it's like, how on an app, on a ride share app, you're going to tell where is your location and where you want to go and you book. Similarly, like, where do you want to go? What is your preferred starting point and the mass, right? How much you're carrying, because it's cargo that's important. And with that, a vehicle itself would be crafted just for you. It's not like, hey, here is a vehicle, fly it or leave it. That is a very SpaceX centric way of doing things, right? That's how SpaceX does it. We want to be a little more on what is the best rocket to build for a mission. So, like, like how we buy laptops, right? You go and you choose the RAM, you choose your monitor, you choose your size of the screen, and so on, right? In a very similar approach, you give all the inputs that you need from a transportation side, and the rocket will be built. Once that rocket has been configured, you will have to then bring a satellite and integrate it with the rocket, right? The rocket sits on the nose cone, the satellite sits on the nose cone of the rocket, and then there is a launch pad where all of the readiness of the launch vehicle, the rocket itself, is taken care of, right? So the fueling, uploading the right software, making sure the batteries are charged. It's like you're getting ready for that moment, right? So all that happens on the launch pad. Then you lift off, and once you lift off, you do a certain set of pre-calculated maneuvers and pre-calculated rotations, and you get to a certain point till your fuel is empty, and then you drop it off. And this is where this reusability part comes in, right? If something is dropped off midway, can you do something about bringing it back? It could be anywhere, right? It could be parachutes, it could be you know catching it with the vertical landing that SpaceX does, or whatever else it is. Why throw away hardware, right? So the reusability part comes. The rest of the rocket goes up to space, and once it goes to space, it enters orbit along with the satellite attached to it. And then what it does is, once the satellite and the rocket are in orbit, it gently gives a nudge to the satellite, and the satellite just drifts away. And this rocket stage that was also in orbit, they slowly deorbited. Basically, they slow themselves down, and the moment you slow yourself down, you start coming falling back in. And once you're below a certain altitude, you'll burn up. So that's how a typical rocket launch works. So in this process, there's a bunch of technologies to be developed in terms of how you make your engines, how you write the software, what algorithms allow you to fly autonomously, what is your flight computer, what kind of electronics are there to get you to function like way you want, and so on. So the way we think about it today, it's a very electronic centric approach. In the past, it was a very mechanical system centric approach, right? It's like my rocket needs engines and tanks, but they have to be sequenced in a certain way so that the engine is started and stopped and my rocket is flown. How we think about it is, a computer wants to go to space. And hey, but you know what? It needs thrust for that. And you know what? There is the engine that's needed for that. Why don't we put the entirety of the rocket engine as a peripheral that can be connected to the computer? Like how you would connect a printer to a computer or a webcam to a computer, right? Very similarly, you connect an engine to the computer. Oh, but wait, you need a fuel tank. Okay, so you can create a fuel tank above the engine, right? Oh, and it has to be shaped aerodynamically because that certain the losses are lesser. So then you shape it. So, but the very core of it is about how do you take a powerful electronics processor to space, and everything that comes in is a add-on, is a peripheral, and that approach allows us to be super modular.
Will you be able to talk about the role with your collaboration and partnership, with IIT Madras and other institutions which are played in technologically advancing your capabilities at Agnikul?
Yeah, so we started off at IIT Madras through Professor Satya Chakravarti's help. And for him to be a part of our company, we had to register with the incubation cell and seek their permission and so on. So that also happened, right? And so we have been a part of that. It's been very helpful in the early years, even more so. I mean, even today it is, but even more so in the early years, mainly because at that point in time, going and telling someone that you're building a rocket was a very complex thing for people to accept. It was an easier story to say you're a part of IIT Madras startup ecosystem, right? So I think there was a lot of that credibility that was lacking at that time for us came from the IIT Madras brand. So very grateful for that. Of course, we got all of the other logistics support as well, right? Access to company secretary, access to lawyers, access to accounting people, access to people who take care of government policies, factories, and all the things that you will need to establish a company. There is a network that you can get in through the IIT Madras store. But the core design and engineering anyway has to be ours. That's our bread and butter, and we do that independently. So that's how we've operated. That's how the point. There are a bunch of
You launched India's first private rocket launchpad. How significant was this for both your company as well as is going to be for India's space ecosystem?
So for us, it's a big milestone, mainly because one of the things that we want to offer that SpaceX can never offer is this ability to launch from multiple launch pads, right? Because the system is too big. It's not the technological capacity. It's just that they're dealing with a huge beast, right? The rocket is too big. And so for us, it was important. Second thing is, it was also very important to prove that when you go to another place and launch, you're not taking enormous amount of time. Like the private launchpad that we had, this was completely first built in Chennai, tested in Chennai, then taken to Sriharikota, and then again installed there, and then we launched from there. So this ability to remove, disassemble, reassemble, requalify launchpads was a big boost for all of us. That was something that we intentionally tried to solve for as well. And finally, I think mobile launch pads are good because, see, if you look at the total cost of doing a launch, there is one piece that comes in terms of what you pay the launch pad, because there you're using their radars for safety, you're using some telemetry with them, and so on, right? So they charge you for that. Now, the more independent you are, the more you have your own launchpad systems. Like for us, launchpad, the mission control room, the plumbing lines, everything was ours. And it was just a mobile system. So we were able to demand more autonomy out of this whole thing. Like we were not stuck because, say, India launch is happening or something, right? That is very helpful. And also, you end up paying lesser to the agency because you bring all of your hardware yourself. There is still going to be some payment, but it's going to be on the lower side because of this. So those were the advantages. Like for us, it was new engine to fly at least, and similarly, new launchpad probably that was something the biggest surprise. We didn't know if ISRO will allow us to build a launchpad. We asked for it and they gave us a permission. The software was completely modular and written from scratch in a plug and play format. It was a controlled flight, a flight where from the get go, you're actually actively gimbaling to keep your trajectory. So these were all like big moments for us because this is what matters to a customer. This is what a commercial flight is going to be about, right? So that is how the launch itself was very relevant for us.
Right, right. You earlier spoke about reusable rocket technology. Is Agnikul exploring that avenue?
Yeah, we're definitely exploring it. Where we'll pull the trigger on that, when we'll do it is one thing, but the vehicle is capable, right? So one of the reasons why we went with liquid propulsion systems, it's possible to bring back a vehicle if you use liquids. If you use solids, it's not even possible. So I think that way, vehicle is capacity wise, it's there. The technology also has been put and tested. So we will be terms of repeatability, right?
The space today, I mean, is flooded with space debris. It's estimated that there is somewhere around 27,000 pieces of debris larger than 10 centimeter actively, tracked by the U.S. space surveillance network. What's your perspective on space debris, and how is Agnikul approaching responsible operation orbit?
So I think space debris is a very important topic. People are becoming very aware and conscious of it. It's a good thing to be responsible that way, but it's also slightly exaggerated in my view. There is always risk, and there is more risk with so many more satellites. But space is big, so there is a lot of clearance as well. But you're going also very fast, so there are those things. So I'm not dismissive, but I do think it's a bit overhyped. But from a space debris standpoint, there are a bunch of things that are happening today, like deorbiting protocols, right? Like you can't simply be up there occupying an orbit. If you're not doing work, you'll have to kick yourself out. Orbits are only given for a particular amount of time, after which you'll again have to kick yourself out. The spent stage, the last stage of the rocket that goes to orbit, you're mandated to deorbit and not simply leave that there as debris. So a lot of these measures are coming up, and I think prevention is really the best way as opposed to going and cleaning it up, because who's going to pay for the cleanup, right? Because if it's an orbit that passes over India, it's also probably passing over some other country, and they are also going to get the benefit. So that means you want to come up with a system where all of them are chipping in equally. It's a space agency level problem, right? So we'll see how that goes. But I think, yeah, everyone is conscious about debris, talking about it, not making sure that they are not dumping more, which is, I think, compared to what we do on Earth, very, very strongly in favor of being, situationally aware, right? At least from a space standpoint. But yeah, we'll have to see how this plays out.
Right, right. The space debris, I mean, becomes a problem because even a tiny fragment, with the velocity that the speed that it travels can be like really, really, dangerous. So I hope that, I mean, these space agencies, they come together and sort out. I mean, because eventually I think it's going to be like a big problem because there's more and more satellites which is flooding the low Earth
But also
orbit.
satellites drop out regularly, Eric. So that's the thing, right? It's not like if you go there and you only stay there. Nowadays, people are mandating deorbiting, and usually a small satellite which is in low Earth orbit, there is just enough tug from the moon and the other planets and all that to gently nudge it out of orbit, and so it will eventually decay. If it's not actively taking care of itself, it will decay. But that may take about a 3-4 year period, right? Or maybe at least a couple of years period. But even that they don't want to do by putting deorbiting and so on. But rightly said, there is more concern. People are more worried that more satellites are going to go, and there is enough work happening around it.
Right, right. How do you see India's private space sector evolving, and what role do you see Agnikul playing in it?
So I think after the announcement of the space policy changes, a lot more startups today are there, right? I think north of 100 are there today, which is great. I think people who have crossed some level of development probably would be in the 10 to 15 range. But there are enough people out there trying to do things, which is great. I think Agnikul has a bigger responsibility because we started early. A lot of people are going to look at us for success to measure how the sector itself is doing. Even though building rocket is an incredibly hard thing to do, uh, it does the way when we started or what who we have become in the sector also gives us some responsibility to deliver on. So we take that very seriously. I, as a founder, take it very seriously that there will be second order effects if we are successful. That the sector itself can grow. So that way, it's important for us to be successful. There is also a lot of support today, so very less worry in terms of what the government will do or what vendors will do and all that. Today, it's about go build the product right, have enough money to build more. You're sorted. That's sort of our focus is.
Right, right. Cool, cool. What lessons from Agnikul's journey would you like to share with the aspiring entrepreneurs, especially in the deep tech space, not just the space tech, the entire deep tech space.
First thing is about gratification coming very sporadically once in a while only. It's not very. It's a lot of things have to happen to get to positive day. For 100 bad days there is one good day. That's how we usually talk about it, right? So that is something that happens. So people have to be ready for that. If you do something today, you're going to see the result of that a year from now or 6 months from now, not tomorrow. Next one, I think it's really about people. It's really about assembling the right team to get the work done. I mean, it's true for any startup, even more so for space startups, because again, the kind of this minimum viable threshold to say that your working product itself is very high. So you can't put out something at a smaller scale and say this works. No, even for something to work, the bar is very high.
You guys are gearing up for the commercial flight. I mean, how you have been gearing up for that will be great if you could talk about that.
Yeah, getting also now we'll have to play, satisfy customers' requirements. So being a lot more customer focused, making sure that their demands are met, making sure that we are able to give them a good ride. We also very cognizant of the fact that what is riding with us is very precious, right? Like it's someone who spent a couple of years making a satellite. For him or her, it's not going to be easy to just dump it on a vehicle and then the vehicle has some problem. So we're very careful and very conscious about that, and also trying to make sure that we really address something that is not available in the market. Right? There's no point in going and offering something that SpaceX can already offer and say, "Hey, we are better or we are cheaper." That's not how you win this game, right? So always go behind what is not in the market and try to offer that in the best possible way. So that focus is constantly there.
Earth has gone through various, I mean, catastrophic issues over the period, and that's the reason I think Elon Musk is looking at maybe colonizing Mars. I mean, when do you think space travel will be accessible for all? It's like a really really far out question, but it will be great if you could talk about your long term vision as well as maybe space travel making it accessible for all.
Yeah, so our vision is to become the best possible space transportation company in the world, and be a customer centric transportation provider, as opposed to what the market is today, which is like, hey, here is a rocket, flight or leave it, right? So that is our vision. In terms of see what the journey is supposed to do, it really depends upon the rider, right? It could be about going to another planet and settling there. It could be about being in orbit and doing some process. It could be about a deep space mission to do asteroid mining. Like as a transportation company, we want to be as indifferent as possible to the final use case. It's like someone wants a ride, can I give them a ride in 2 weeks? Can I give them a ride at a price where no one else is even close to it? And can I add on a lot of features so that it really adds value to them? So that is our approach to building Agnikul, right? And for that, every single bit of technology that has gone into Agnikul, we have designed from scratch in house. So when I talk about our vehicle Agniban, for me, it's Agniban is an amalgamation of technologies that you've developed in house. And today it is being put together as Agniban. Tomorrow it can be put together as something else, some other space transportation system. But the idea is to always be the market leader in space transportation.
Thank you for taking time being part of the podcast. You guys have been part of, creating history by creating the first 3D printed rocket launcher. Then you have opened up India's first private rocket launch pad, then a mobile launch pad. more power to you and the entire team. And I hope that what you do inspires the next gen of not just space tech, but also deep tech entrepreneurs. And I hope that we have more entrepreneurs here in India who are building from first principles thinking. You building something which is completely original. So more power to you guys for your commercial flight due this year. And to my listeners, if you like what you see in here, please press the subscribe button. Until next time, see you guys. Bye. Thank you.